Hello. In this video, I will do a GED video regarding objects at scale. So this will be a very short video. Well, will be only 3 questions. That's what I really mean. But yeah. So we're going to talk about objects at scale. Um, this is very equivalent to proportions, uh, word problems. So before I start, I want to talk about the rules for setting up proportion because this is what it really is. It's just proportion problem. Object and scales are basically proportion problems. Okay, so go ahead and write this down in your notes because this is kind of important. So for setting up proportions. Okay, so the first rule is you set a proportion. You can set up your proportion any way you like, as long as the units matches. So what does that mean? So I'll show you an example. I do this example, but yeah, you can set it up. You can set a proportion any way you like. Um, Units matches. Wait, I don't know. You'll see what I mean when I do an example. Rule two. So this applies to all proportion problems. You must have only one unknown value. So if you have two unknown values, that means you either did something wrong or yeah. So you must have only one unknown value. So if you have no unknown value, that means you also did it wrong. If you have more than one, like two unknown values, you either have to convert something or you did something wrong, right? Then what I would do is once you set it up and you have your all your known and unknown values, you cross multiply. And then step four, solve for unknown. That's it. Easy peasy, right? So yeah, step one, you set a proportion any way you like as long as the units matches. Step two, you must have only one unknown value. Step three, cross multiply. Step four, solve for unknown. Okay, I'm gonna click. If you need to pause the video to want write the steps, go ahead and pause it. But I am going to clear and I am going to do the first example. Okay, so let's do example one, question one. So question one says a model train is set a model train set is designed with a scale where 2 centimeters represents 8 meters of natural train. If the actual train is 40 meters long, how long should the model train be to maintain the scale? So this is definitely a proportion word problem. So you're going to set it up like this. If you have, so proportion, this is how you set it up. You've probably seen it before. So you have like this horizontal line and then this equal sign and then this horizontal line. Okay. So then what you do is you can set it up, then you figure out your units. So you can set it up any way you like. Right. So you can set it up. So what are our units? We have they said something about centimeters and then they said something about meters. So what that means is you can put centimeters here and meters here. But if you do so, that means over here, this should be centimeters and then this should be meters, okay? This cannot be meters here, centimeters there, right? This has to match with this, and then this has to match with that, right? You could have also, because you know how I said you could do it any way you like. You could have also put meters on the top and centimeters on the bottom. And then if you do that, this has to be meters on the top, centimeters on the bottom. Okay, so it's really up to you. You can get kind of creative. But I'm going to put, because I already did this on my notes, I'm going to put centimeters on the top, meters on the bottom, centimeters on the top, and meters on the bottom, right? So let's figure out what do we put in it. So it says a model train is designed with a scale with where 2 centimeters, so put 2 here, represents 8 meters. So you can put 8 here. If the actual train is 48 meters, so over here you're going to put 48. Uh, how long should the model train be to maintain the scale? So that means our unknown is our centimeter. So that's going to be our x. Okay. Does that make sense? Okay, then what we do is step two, you're going to cross multiply. So 8 times x is 8x equals, and then 2 times 48, 2 times 48. Or I'll use parentheses to represent multiplication. And then step three, solve for x. So before I solve for x, simplify the right? What is 2 times 48? 96. Then you have 8x. And then go ahead and solve for x. You're going to divide both sides by 8. And then you get 96 divided by 8. Okay, so that's your answer, 12 centimeters. So how long is that? Should the model train be to maintain the scale? 12 centimeters. Right, easy peasy. Okay, let's move on to the second question. Okay, question two says the width of a rectangular garden on a blueprint is 10 centimeters, and the scale is 1 centimeters equals 5 meters. What is the actual width of the garden? So yeah, this is also just like number one. It is a proportion word problem. So imagine you have two rectangular garden. One is in scale, and then the other one is the actual, right? Actual. Here you have the length, and here you have the width. Here you have the length, and then you have the width. So, um, set up our proportion. But what are our units? You have centimeters. And then you also have meters. So you put that here. And then this could be centimeters. And this could be feet. So let's see. Our blueprint, it is 10 centimeters. So you could put 10 here. And the scale is 1 centimeters equals 5 meters. So this piece of information says 1 centimeter equals 5 meters. What is the actual width? So our width is this meter, which is x, and then you put this known information on the right. So just put exactly what it says. So we have 1 centimeter, so you put one here, and then 5 meters down here. Okay. So once you set it up, go ahead and cross multiply. So 1 times x is x, and then 10 times 5 is 50. Okay. So our final answer is 15 meters. Okay, that's it. So what makes proportion word problems difficult is sometimes you might have to convert they might have not have it in centimeters and meters. You might have to do an extra conversion. So that's where it can get a little bit tricky. Okay, question three. The last one for this one, I told you this could be very short. But when we actually do practice exams, this will pop up, so it's good to know. So question three says, a detailed map shows the distance between river town and mountain views as 8 centimeters. The scale of the map is 1.2 centimeters equals to 60 miles. How far apart are the actual cities? So yeah, have you ever seen a map? You obviously know that when you're looking at the map, it's not drawn to scale, right? So that's what they're doing. So you don't have to draw an image. You can just set up your proportion. And what are our units? So we are given centimeters and miles, right? So that's what you have to do. Just look at your units. We have centimeters. You can put centimeters on the top and miles on the bottom. And over here, if you do that, this has to be centimeters on the top and miles on the bottom, right? Okay, then just fill in the blanks. So it says the scale map is 1.2 centimeters, which is 60 miles. So that's an information you can just put in. So for 1.2 centimeters, it's going to be 60 miles. And then what are they asking? How far apart is actual cities? So I believe that's our unknown is our miles. And what else do they tell us? A detailed map shows the distance between River Town and Mountain View as 8 centimeters. You're going to put 8 here. Okay, go ahead and cross multiply. So this is going to be 60 times 8 equals to 1.2 times x. Okay, and then I guess you can multiply the left side. So what's 60 times 8? 480. 1.2x. And then divide this by 1.2. And you get x equals 400 miles. That's it. Okay, so this is a fairly short video, but yeah. Yeah, let me check my work real quick. Okay, so we got it all right. So yeah, that is the first taste of proportion word problems. Okay, it will definitely come up. So yeah, I'm gonna stop here.